Hello and welcome to another PICKItPlus demonstration. This time I'm going to be taking you through creation of a tiny bootloader for the PIC16, I'm so sorry, the 18F16Q41. Let me take you out to my tools that I've got. Look, I've got going to be going through the GC Basic editor because that's what we use, the IDE, that's what we use. I'm going to take you through, let me just show you camera. There is down here, there's a Q41, there's an LED, and there's a serial connection in here on the two ports the user has specified. And currently that is El Morto, or dead. What I mean by that, it's not operating. I'll just show you that. I'll bring up PICKItPlus. I'm just going to use that for power. There's no power going into that, so I'll just turn the power on. That's fine. And I've got this tiny bootloader application that says that I'm going to do a check device, and it's not going to reset it because there's nothing in there because I had previously erased it. Take you through code generation. Really simple, just to explain what we do. So this code here has been generated or written about a year ago. A huge investment of time. And what it is a configurator to generate tiny bootloaders. And it's worthwhile showing it to you. So look, I've got a couple of things. It's pretty well documented, but a couple of things we have to do. We have to tell it what chip it is. I've already put that in. Q41, 16 Q41, 16 megahertz. Doesn't really matter what we set it to because the user program can change the frequency of the chip, but we like to operate at 16, 8, or 4 megahertz. That's because it just helps our calculations. Okay. We have to do some configuration. Configurations are baud rates, startup delays, if they're using HEF. If they want to use COM-port2, there's no point using USART2, to be quite frank. People don't, because we're going to use PPS. PPS, we're going to come into to do a PPS. Have a look down here, 16Q41, and it says here set up the transmit on C4, set up the receive on C5, and I just set up the answer. Just need to do those three things. It's pretty simple to work that out. The rest of it is sort of done for you. We'll collapse that down. Then what I'm going to do, the rest of this is just a mass of assembler. Okay, but it's all used inside of the GC Basic framework. So if I look at the type of code that's in here, it will have things like this. For this particular chip, it will say wait for the application to start. That's the PC application. Send that a NAC. Should really be a NAC. Get the address that it's got to write to. Get the data. Make sure the checksums and the flag bits are correct. And then write out the flash or EEPROM. Once that's been completed, it will unlock the write and then flush out these buffers that we've created. And so we're doing all that. We'll have a look at the send NAC. Dead easy. Here's the main loop that it says here. Put the bootloader family that it has determined. So a lot of backend inside of here is intelligence in terms of calculating the type of bootloader family it is, and so that it gets all that is self-calculated within the scripting engine. It puts that in the W, and then it will send it out to the serial port using indirect addressing. Complicated? Doesn't have to be. It's not really that complicated because it's all embedded. And we're using assembler because we've got ASM written in front of it. We might do, this is a quick insight. There's some other stuff. Here we are. Look, we have some raw ASM and ASM. And the difference here being in that we're doing a call here to receive a character, and then we're sending back. We're comparing that to a C1. And if it's not that C1, it will go out to the exit address or label. If it is found a C1, it will then send the ID PIC out on the W, and then we'll get it transmitted out on the correct register. And we use raw ASM and ASM because sometimes we want to use GC Basic to do substitution of variables and constants. And so we have a choice of what we can do. And so, but it doesn't really matter because all I'm going to do is press function key F5 in the IDE. And the IDE will now, I'll zoom out for you, We'll now compile that. It will pass this source file out to PIC18. It's assembled it in PICKItPlus, and now it's programming it using PICKItPlus. We know that it's done that in a moment because it will say done, and it says done on the screen. I can now do a check device inside of TinyBootLoader, and it says it's done it. Do it again, check complete. Okay, that's interesting. So I've written a quick test program. Here it is. It's a test program. It's basically this chip, 1641, flashing LED on port A2. I'll just compile that up, press function key F5, and it has just compiled that. That's great. Let's go back to TinyBootLoader, and I've already pre-selected my selected file here, browse. I can find my source file here. It was called that. I can do it a different way. Copy path, paste it into here, change that from GCB to hex, and now I've got my program. I can write it out. Well, how do I know it's written it out? Because hidden behind here is an LED that's flashing. Hey, let's change the code in here. Put that to 100 milliseconds. Put that to 90 milliseconds, 900 milliseconds. Press function key F6. We'll see that compile that. That has compiled it. I will then write that out. It would help if I did it properly. There we go. And it is now flashing at a different rate. We know it's working. What it's done. The second time it's put it in, we know the bootloader's working because the first time it might have been luck. The second time, trust me, bootloaders aren't lucky like that. Here is PICKItPlus. I'll just read that chip very quickly. And what it's going to do is just put that in memory for us so we can have a quick look at it. And here we have the program. Here we have the jump call to the bootloader, and here we have the user program sitting in the correct level of memory. That's essentially this block here. If we move to the top of memory, we can see there's the jump code back to the user program, but here is the bootloader sitting here at FF00. All that memory addressing, all the identifiers, all this source code is inside of the GC Basic source program. We let people have the hex. To be quite frank, they give us some money for it. We'll also license the assembler so that you can actually do this on your own. We'll also, which means we'll give you the .s source, so you can compile that up under license. And then we also do the same license agreements for the GC Basic source. That's more expensive because you're getting all our tooling. The goal here is for us to put this on the web so that people can go in, make a small payment, and get their own tiny bootloader. So what I wanted to show you is generation of a bootloader for the PICK18FxQ20 microchip PIC. Enjoy.